We've touched briefly on a great many issues in the philosophy of science. I say briefly because each one of them could be studied much more deeply, should be studied much more deeply. But our objective for today is to go over some of the things that we've looked at, to summarize them, and to see if there's any conclusions that can be drawn about the philosophy of science. After these many weeks of talking about different philosophers of science and their approach starting from the mid-19th century up to pretty recently, you might have the impression that the upshot of all this philosophy of science is to kind of debunk science. I've left some of those matters not entirely settled. For example, the sequence that goes verificationists, falsificationists, Kuhn, and Lakatos, that particular sequence doesn't altogether end with Lakatos's conclusion that science, after all, is rational. Lakatos tries to argue with Kuhn's contention that the decision between competing paradigms, that decision is a non-rational decision based on other than rational criteria. Lakatos tries to re-understand science in terms not of theories, not of paradigms, but in terms of what he calls scientific research programs. And those things, Lakatos says, can be rationally appraised. You can assess some of them as being progressive, others are regressive. And what Lakatos says the rational decision is to, of course, choose the progressive scientific research programs and don't choose the regressive scientific research programs. Unfortunately, Lakatos himself pointed out that the question as to which scientific research programs were progressive and which regressive really can't be settled until the dust is cleared after the Kuhnian revolution. If research programs are in competition, it may very well be the case that a research program will appear to be regressive for a long, long period of time, only to redeem itself later on. So that a research program that looks regressive might, in fact, in the end, in the long run, show itself to be progressive, and vice versa. One that seems to be having a great deal of success in the short run might very well, in the long haul, prove not to be fruitful in the ways that it was thought to be by some of its proponents. So for Lakatos, the rationality of science, or at least the rationality in deciding which of two competing research programs we should choose, has to do with choosing the one that is progressive. We should go with that one. We should adopt it. We should use it in our work. We should become a supporter of the progressive scientific research programs. Unfortunately, for the rationality part of this view, it's not easy to assess. In fact, it's quite impossible to assess on anything other than a speculative basis from the middle of the battle, it's impossible to assess which ones are rational, which ones are irrational, which ones are progressive, which ones are regressive. So once again, for all of Lakatos's heroic efforts, it appears we're left with this conclusion that these decisions are not things that are driven anyway. They're not determined by data. They're not determined by logic. And there is a heavy component of judgment that goes into the decision about which of two competing research programs one should go with, just as there was with Kuhn. Judgments that are eminently fallible, judgments that can go awry. It's easy to make the wrong judgment. The most competent scientist might very well make the wrong estimate about which theory will be the one that gets accepted in the long run. There's just not sufficient data to make the decision. And that's what Kuhn meant by saying that the whole movement of science from one paradigm to the next was not rational. It was driven by other than criteria of strict reason. I want to mention another name in connection with that particular development. Beyond Lakatos, we get a fairly radical view, one that's not representative of philosophers of science, but it kind of represents what might seem to be the upshot of this whole sequence of thinkers. Paul Feyerabend wrote a book called Against Method, which is against method. He argues in the book that there's no such thing as scientific method. There is nothing that all scientists share in their approach to their attempts to understand the world. If you think about it, it makes a certain kind of intuitive sense right off the bat. It's hard to imagine that there's very much that contemporary molecular biologists, for example, might share with Galileo. It's very difficult to figure out how to pin down any kind of method that scientists use. And Feyerabend emphasizes the role that hunches plays, the role that stubborn commitment plays. He emphasizes these things and argues that there is no method, that anarchy reigns in science, that whatever succeeds in along criteria that at that particular moment happen to be the dominant ones, whatever succeeds on those criteria will be the victor, but the criteria shift. The criteria for deciding between scientific theories shifts constantly. And rhetoric and polemic, this is kind of like a radical Kuhnian view. Rhetoric and polemic are more important than logic and evidence in defending scientific theories. Now, I say it's a radical Kuhnian view. That might sound just like Kuhn up to a certain point. But Kuhn shared with all those other philosophers of science we discussed, he shared a kind of commitment to the superiority, somehow, of science in understanding the world around us. For all his emphasis on non-rational decisions and the importance of judgment, the importance of aesthetic criteria in deciding which of two competing paradigms to choose, for all of that, he still liked science. He still thought science had something going for it that made it superior in gaining knowledge anyway, or in gaining understanding, to, say, philosophy in many respects. I mean, it's not, he wasn't trying to put down philosophy either. It's just that there's some unique sorts of features that can be identified in science that allows it to make a certain kind of progress anyway. And I think it's fair to say that Kuhn placed what you might think of as his demarcation criterion, his way of distinguishing between science and non-science. He placed it, he associated it closely with this idea of normal science. What science and sciences, let's put it that way, what sciences have going for them, and this was our original question, if you'll remember, what sciences have going for them, what distinguishes science from non-science for Kuhn seems to be the ability within any science to establish some kind of science-wide agreement on the basics. What allows science to at least make progress within a period of normal science is that there is not incessant bickering among the practitioners of the field about the basics. This is one of the things that distinguishes physics from philosophy, but it also may distinguish the harder sciences from the softer sciences. The softer sciences, the social sciences, say, are somewhere in limbo between the pretty universal commitment to basics among physicists and chemists, say, and the near anarchy within disciplines like philosophy, where no two people seem to agree on anything. Somewhere in the middle are the social sciences, where there is at least there's the formation of schools of psychology, say. And within the school, a certain school of psychology, like behaviorism or Freudianism, within one school or another, you at least get something like this same widespread agreement, which has the following beneficial effect. It allows people to make progress. It allows the scientists to move beyond arguments over the fundamentals and to see just how much work can be done by the theory. So even Kuhn thought that there was something beneficial about the way science works. His criterion of demarcation isn't a logical one. It doesn't depend on the use of tests. So he's very, very different from the verificationist and the falsificationist. But he still thinks there's something beneficial and useful about science. I want to mention Feyerabend again in this connection. I want to bring him back in here because it's fairly clear that he doesn't share this view. He's one of the few people in the philosophy of science who really does see himself, I think, as debunking science. And what I'm going to do this evening is try to show you that it's really not accurate to speak of philosophy of science as being an effort to debunk or discredit or undervalue or diminish in value the whole idea of science. That's a misunderstanding. But there are some, like Feyerabend, who offer fairly powerful arguments just in support of that thesis. Feyerabend thinks that science has actually become the modern cult, the modern religion. It's almost as if, as far as Feyerabend can see, the hopes of Auguste Comte back there in the 19th century, that one day science would become society's religion, that those hopes had actually come to pass. Let me quote something for you that Feyerabend finds especially illuminating in this regard, a very good illustration of this sort of thing. It's one among many, but he wrote an article it was in 1978, in response to another item that had appeared in a magazine in 1975. Here is a statement made, actually as part of a little article entitled, "A Statement by 186 Leading Scientists." And I'm just going to read you part of it. The statement itself only runs about 5 or 6 paragraphs. I'll read the first paragraph. "Scientists in a variety of fields have become concerned about the increased acceptance of astrology in many parts of the world. We, the undersigned, astronomers, astrophysicists, and scientists in other fields, wish to caution the public against the unquestioning acceptance of the predictions and advice given privately and publicly by astrologers. Those who wish to believe in astrology should realize that there is no scientific foundation for its tenets." And then it goes on. It's a petition, you see, and so it goes on for another 5 paragraphs. It's not very long, but it continues in that same vein, trying to explain why people might believe these things and how it really is outdated and doesn't really offer any reasoning. It just persists in the claim that astrology is not scientific and is misleading. And then beneath are the signatures of Paul Kurtz and a couple of others who initiated the petition, but then follow the signatures of 186 leading scientists, among whom are 18 Nobel Prize winners. So what the Humanists printed was a statement, a petition by 186 leading scientists cautioning the public that astrology was not wise to believe it. It was not scientific. It was foolish. It was dangerous in some ways. Well, Feyerabend thought that was really quite precious. Feyerabend believes that science once was a very liberating undertaking, that there was a time when dogma, church dogma in particular, held humanity in shackles, in chains, kept people from thinking for themselves, kept people from thinking creatively. And it was science which played the important role. If we're able to figure out what science is at all, it was something like ideals that people associated anyway with science that helped to free a large part of humanity from those particular shackles. As you know, those particular shackles still hold a large part of humanity as well, so it's not like everybody got liberated. But Feyerabend is prepared to concede that science has played a remarkably important role in freeing the human mind. But what Feyerabend is bothered by is that in the late 20th century, the human mind now seems to be tied to science. If a scientist says something, it's okay. Look at what commercials do. Commercials trot scientists on to explain how wonderful a certain product is, with the implication that one should believe this. The scientist says so. Scientists make statements on the craziest of subjects. One of the things Feyerabend points out is that in this list of 186 leading scientists, there's not very many at all there who would have the kind of expertise necessary to be able to offer an argument against astrology. Feyerabend points out there is no argument offered in this statement. Here are 186 leading scientists saying, look, I'm a scientist, and I'm telling you this stuff is nuts. Don't believe it. That's the method of authority, Feyerabend points out. And too often, people are once again prepared to do things, prepared to believe things on the method of authority. We are taught the principles of science in our schools. How many of us really have looked at any alternatives? How many scientists have ever looked at any alternatives? Kuhn, at one point, and Feyerabend would agree with this, Kuhn argued that science really isn't marked, the training of the scientists really isn't marked by its efforts to encourage criticism and self-criticism. That's not what marks the training of a scientist. If you are too critical, if you are too philosophical, you may very well not succeed as a scientist. You need to be able to accept from your teachers the idea that certain procedures really must be learned. These are the ones that must be mastered. You need to do that because you're going to have to spend long, long years mastering those techniques. Mastering the mathematical techniques, mastering the experimental techniques, understanding the theory. You more or less have to apprentice yourself to your teachers. And Kuhn, at one point, called attention to the fact that this is closest to theological training. If there is anything that, this is very strange, but if there's anything that the training of a scientist resembles, it's theological training, training in some particular theology, where you learn the doctrines of your master, you learn them very well, you internalize them, you make them your own, you put yourself in a position where you see through the eyes of your teachers, of your master, where you take over a way of looking at things that is the scientist's way. Kuhn didn't really claim that that was all that went into the training of a scientist. He acknowledged that, that other things, or at least he said, I shouldn't say acknowledged, he said that other things too, need to go into the training of a scientist. There has to be some degree of criticism and preparation for theories going wrong. Kuhn argued that way. Feyerabend is not so sure. Feyerabend sees the quasi-theological training and argues that more than anything else, what we're getting is a particular way of looking at the world. It's encouraged, let's say, by physics, a particular way of looking at the world that can indeed be pushed further and further and further into greater and greater detail, but it's a cult. It's a cult. And the rest of us, those outside science, sort of are left with the same kind of awe concerning the scientists that other generations of human beings had for their priests. And what Feyerabend argues is that, once again, just as was the case in the Middle Ages, we need liberation. If we don't understand the things that we're being told, if we don't look critically at the principles of science, the principles of physics, if we don't look at them with a critical eye, then we are no more using our reason, using our native intelligence. We are no more liberated than was the citizen of the 13th century who simply accepted the reasoning of the monks, of the priests. So Feyerabend thinks that what we need is liberation. He would argue that science in particular shouldn't get funding by society. That if we are going to fund anything, and he says this, I think, partly tongue-in-cheek, if we're going to fund anything, we should fund everything. So there should be, funding for magicians and funding for astrologers and funding for everybody else. I guess that's tongue-in-cheek. Probably what he would really recommend is that we fund none of them. We let them survive. We see what really will survive without funding. If science survives, so be it. Feyerabend, to be sure, is a debunker. He thinks science needs debunking. I mention him because that is almost the logical culmination to this series that starts with the 19th century positivists. We talked a little bit about them, and we talked about their 20th century verificationist successors. We talked about the falsificationists. All of those folks were committed to the rationality of science. Kuhn enunciates a discomfort with that kind of view that had been long-standing but not dominant in philosophy of science. Kuhn suggests, well, things aren't quite they're not as rational as they may appear. Lakatos attempts to reassert that rationality, but whether he succeeds in doing that is dubious, because, as I mentioned, it's not clear how one's supposed to assess the progressiveness or the regressiveness of a research program from in the middle of the conflict. It's easy to do it after the battle is over. You can say, aha, now I know which one was successful. But it's very difficult from the middle of the conflict to figure out which one will, in the end, be progressive and which one regressive. Feyerabend takes that as a concession that science and these decisions within science are non-rational after all, and argues that perhaps we are a bit too obsessed about science and its alleged superior rationality. Nonetheless, Feyerabend is the exception. For the most part, to this day, philosophers of science do not think of themselves as debunkers. Indeed, they are fans of science. They're attracted to science because of its success. But there's other sort of tendencies in the lectures that we've had that might lead you to think the same thing, that science is being debunked. For example, in our discussion about realism and conventionalism, after we'd gone through a variety of different consideration, we saw that empiricists say that theories, anyway, are just conventions, that observations are the only things that really count, that we shouldn't take our theories seriously, the empiricists or the instrumentalists, conventionalists. And the constructivists, the social constructivists, seem to say that not just the theories, but everything that we can say about the world is in some sense a construction or a convention. And even the realists seem to acknowledge the theory-ladenness of observation although they take it that that speaks well for theory, whereas I guess the constructivists might be taken as saying that that speaks poorly of observation. But that the theory and observation are not so distinct, that's something that both the constructivists and the realists seem to agree on. But the upshot seems to be that our contact with the world is by way of conventions of some kind. Perhaps not arbitrary conventions, but conventions of some kind. That might strike you as being a way of criticizing science. Again, it's not. But I want to acknowledge what might appear to be the case, the trend in all of these discussions. At the end, I want to try and explain why it might appear this way. And finally, even when we talk about scientific explanation, we offered some very nice-looking models, the deductive nomological model, the probabilistic model of explanation. But in each case, there were problems that were left unresolved. With regard to the deductive nomological kind of explanation, there were certain asymmetries that weren't explained on that model. You remember I talked about the flagpole. If we know what the position of the flagpole is, and if we know the position of the sun, and if we know the laws of optics, then we should be able to predict the length of the shadow. And we could deduce what the length of the shadow should be on a very nice deductive nomological model. And that looks plausible. The deductive nomological, the DN model, I'll abbreviate it. The DN model appears for all the world to really account for account for how we've explained it. We've shown that it can be deduced as a consequence from these initial conditions and these laws. But unfortunately, you could also deduce the height of the flagpole from the remainder of the information. You could have, if you know what the length of the shadow is and the laws of optics and the position of the sun, then you could deduce the height of the flagpole. It hardly seems reasonable to say that the height of the flagpole is explained by the length of the shadow. It seems like there's an asymmetry there that isn't captured in the deductive nomological model. And we waved our hand, I waved my hand, at the possibility that causality is what's going on in there. The one extra factor that you'd need to have in order to show why the height of the flagpole plus these other things explains the length of the shadow, but not the other way around, is that the direction of causality goes sun, flagpole, shadow, not sun, shadow, flagpole. And so it seems that all we might have to do in order to clarify this deductive nomological model is to add some remark about cause. But cause is notoriously difficult to define. What is it that we recognize when we recognize that something has caused something else has been terribly difficult to define through history. And for many people in the 20th century, David Hume's analysis that there isn't anything there that to be recognized or to be picked up. It is more a matter of our own habits than it is a matter of recognizing something in nature. That analysis is very, very difficult to avoid. So it seems unfortunate in a way, first of all, for historical reasons, that we have to bring cause into our account of scientific explanation. If we'd been able to do it the way Hempel wanted to do, just in terms of logic, boy, that would have been nice. Trying to bring cause in is problematic for philosophical reasons, because of David Hume's arguments. And it's problematic also for scientific reasons, because in the 20th century we seem to have sciences, entire areas of science anyway, which not only don't explain things on the basis of their causal order, but can't. Quantum mechanics in particular suggests that causation is just an irrelevant category when we get down to the level of the quantum, get down to the level of the structure of the atom. So for both philosophical and scientific reasons, it's a little bit bewildering to try and figure out how we're supposed to understand even something as simple as scientific explanation. And the probabilistic explanations, they had trouble too. We noted that in order to appreciate a probabilistic explanation, we had to position it within a contrast class. We talked about trying to explain why someone contracted the measles. And if the contrast class is the entire population of human beings, we can use the following probabilistic argument. We can say, well, Joe contracted the measles because he was exposed to the measles, and as a general rule, people who are exposed to the measles will probably, and you might even be able to quantify that statistically, will probably get measles themselves. Again, if what we're trying to do is explain Joe's coming down with the measles against all of humanity, that serves as some kind of explanation. We said, well, he's contracted the measles. And it follows that, he's contracted, I'm sorry, he was exposed to the measles. And it follows through probabilistic inference that if he was exposed to the measles, and if most people who are exposed to the measles get the measles, then he has some sizable probability of getting the measles. But we're not able to explain, given that argument, why Joe got the measles and someone else who someone else who was also exposed but didn't get the measles. We can't explain the difference between Joe and that other person. So if the contrast class is everybody who was exposed to measles, then we lack an explanation of why Joe got them and the other people didn't. So probabilistic explanation also seems problematic, especially because of this reliance upon contrast class. And for many, it's been hard to avoid the conclusion that what explains something is really more a subjective matter than an objective matter. If you take all these problems into consideration, it has led some people to despair of constructing general models of explanation, and has led rather to the conclusion that explanation is a matter of making something clear to someone, given their background knowledge, given their own beliefs. So all of this kind of rolls up together. We also talked about how values enter in, value judgments, assessments of importance of one thing or another, how those enter into even the decision the decisions about whether a particular conclusion is warranted on some particular set of data, whether the data is adequate to draw a particular conclusion. That judgment is not something that you can just make, period. It depends in large part upon what hangs on the application of your conclusion. And if some dire consequence will occur if you are wrong, if you are mistaken in drawing a conclusion from the data, then you'll probably require a great deal more support than you would if nothing much that was important hangs on it. And of course, these matters of what's important and what's not, those aren't scientific judgments, by and large. And they're very often ethical judgments, especially when we're talking about research into medicines that human beings will take. Through all of this apparent not debunking, but at least questioning of science, questioning led by people who seem to think of scientific decision-making as not being driven by evidence exclusively, not being driven by logic. I want to assure you that it really isn't an effort to debunk science or to suggest that its value is not great. Most of the people who've been involved in this effort have been convinced of the extraordinary value of science. What's been debunked, I think, is a certain kind of glorification of science, a tendency to put science up on a pedestal that reached its apex, perhaps, in the 19th century, and which I described very early on in the quarter in terms of 19th century positivism, as almost wishing to make, explicitly wishing to make of science a religion, because it was so superior to philosophy, so superior to metaphysics, so superior to religion. It's that view of science that I think has been effectively debunked in the 20th century. It's not science. Science really is a remarkably important, remarkably valuable undertaking. It is whatever it is, and we've gotten some clarity about some issues, but I'm not sure that we have a very sharp line now between science and non-science. In fact, the tendency of all of this discussion seems to me to lead to the conclusion that the line isn't that sharp at all, and we shouldn't expect it to be. That science mixes in an awful lot of conjecture, an awful lot of creativity and guesswork, that it relies upon stubborn commitment sometimes. All of these very human factors. The point, I think, if there is one, of this, the tendency, I shouldn't say the point because it's not something someone intended, but the tendency of this work in the 20th century is to do just what Darrell suggested. It's to try to look more closely and in more detail at science. And when you look more closely and in greater detail, what you find is something that is relatively fuzzy at the edges. I mean, science is not something that can be sharply distinguished from other enterprises. There is no particular method that you could write down on a page, like the deductive nomological method of scientific explanation, or or modus tollens, or any other kind of logical procedure that you could put down on a page that would explain what it is that all scientists do in all sciences across all periods of their history. There's nothing that's that simple or that plain. You could say vague things like science tends to try to pursue lines of inquiry as long as they are of value, and that it does put a certain premium on not giving up too quickly, not giving up on a theory or a paradigm or research program, depending on your preferred terminology, not giving up too quickly. It does seem to put a premium on being able to master the techniques before you throw them down. And so that the idea that scientists need to be prepared to do a lot of hard work in learning the methods of the sciences before they are encouraged to criticize those methods, that's right. But again, that may very well be one of the virtues of science. It's one of the things that makes it successful. It seems to me that what you wind up with is a point of view about science that makes it, that embeds it firmly, in human undertakings of all kinds. Science isn't something that's standoffish. That's, the 19th century view seemed to imagine the scientist as someone who could kind of coldly appraise the world around without involvement in it. We can't do that. And the very cutting edge of physics is one, in quantum mechanics anyway, where the involvement of the theoretician has to be, the involvement of the experimenter has to be taken into account theoretically. It has to be written in to your understanding of the situation. You cannot neglect the effect of the experimenter on the experiment. You cannot neglect the interaction of the observer with the observed in physics any more than you can in anthropology. So the lines are fuzzier. What once seemed to be a pristine sort of cool, logical, almost non-human undertaking, perhaps a divine undertaking in the views of some, is really a great deal more human, a great deal more like other undertakings than it was held to be in the 19th century. So what I want to leave you with is just this, the thought that, that science does appear whatever science is, it appears to offer us our best avenue toward broadening and deepening our understanding of the world. How it does this is probably quite various. There probably isn't a single way it does this. There's probably not some way that biologists, physicists, chemists, all scientists must proceed in order to do this. It's probably something like a picking yourself up by your bootstraps sort of undertaking. You try something. It seems to work. You continue it. It doesn't. It gets you into trouble. You try something else. But there is a certain discipline and tenacity about the scientist that I think we've captured a little bit of that makes science different than speculative philosophy. And just in that difference, perhaps, it will always continue to interest philosophers because philosophers have always been interested in ways of knowing.
We've reviewed a number of different views about what science is, about how it works, about why it should work, from a logical basis, historical, social basis, a lot of different approaches to science. But what's fairly uncontroversial among philosophers of science is that science does work. What philosophers are interested in is what makes it work. They want to figure out what science has going for it. Why is it that science can present us with conclusions that seem to be better founded than any other approach that we're able to take? Science is very special in the history of human affairs, and we've been studying it in this series from a philosophical point of view. We've just scratched the surface. I hope your interest has been whetted. I hope you'll pursue this matter, as I will, in the future. But at least we've given you an introduction to the philosophy of science. Thank you.
Thank you.